A steel bar of rectangular cross section 55 by 45 mm, pinned at each end and subjected to axial compression. The bar is 2.3 meter long and E is equal to 210 GPa. Compare Euler's critical load with Rankine load. Take sigma C is equal to 550 megapascal and A is equal to 1 by 1600. Right? This is for 7 marks. Most of the numericals in your exam for buckling load is for 7 marks, and for torsion it is for 6 marks. Torsion numericals are relatively simple. You have one torsion formula which you have to use for all the types of cases. Now let us try to solve. Solution. Okay, so it is a rectangular cross section. Let me just draw a small rectangular cross section. 55 by 45. So this is 55 and this is 45. Just put this. This is 55 and this is 45. Right? Now by symmetry, I know that the center of gravity is in the midway of this. Okay, this is XX and let us say this is YY. Let me just name these directions. This is my X, X, Y, Y. Okay, and this is the center of gravity G. I'll just show that. So this is my center of gravity. Now let me take this diagram. Let it be. Okay, now let us note down the given data. The cross section is 55 by 45. So B is equal to 45 mm. D is equal to 55 mm. It is pinned at both the ends. So let us go to this. Pinned means it is hinged. So when both the ends are hinged, LE is equal to L. So LE is equal to L, and that is equal to 2.3 meter. Okay. E is given Young's modulus 210 GPa, which is equal to 210 000 MPa or Newton per millimeter square. Sigma C is given. So this is sigma C is equal to 550 megapascal or Newton per mm square, and Rankine's constant A is equal to 1 by 1600. So you have to compare Euler's critical load and with Rankine's critical load. Now the Euler's critical load is given by pi square EI by LE square. Now E is the moment of inertia of this cross section. Now should we take BD cube by 12 or DB cube by 12? That is the question. So what we have to do is we have to find moment of inertia in both xx and yy direction, and whichever is the least value we will take that, because the column will tend to bend in that direction. Okay, so let us find moment of inertia first. Moment of inertia in xx direction. Ixx is equal to xx is this, so it will be b d cube. So b d cube by 12. So let us put the values and just copy this again. Yeah. Now b in this case is 45. And d is 55. This is equal to, let us calculate this, 45 into 55 cube by 12. It is this value. mm goes to 4. Let me just do it. Now the same thing I have to do for yy direction, so I'll just copy this to save time. In yy direction, so this Iyy. Now in yy direction, this is depth and this is the width, so it will become reverse now. So it is db cube by 12, so it will become 55 into 45 cube by 12. Obviously this will be smaller, so 55 into 45 cube by 12, right? So it is this much. So Iyy is small, so the beam will bend like this, right? Because this cross section is less, so it will bend in this direction or in this direction, not in this direction. Since Iyy is less than Ixx, buckle in yy direction. avoid using bend in this section because bending is completely different. Bending is when a beam, that is horizontal beam, is subjected to bending moment, it tries to deflect, right? Buckling is a vertical column when you are subjecting it under axial compressive load, it is trying to bend. That is called buckling, right? So there is a very thin difference between this. Now I have I, so I can find the Euler's crippling load. Euler's given by, I just kept the formulas here handy. So PE is equal to pi square EI by LE square, or now let us put the values. Pi square is a constant, so no need to do anything. E and I. E is how much? 210. 210 into 10 raised to 3, or I'll just put it as 210,000 into I. I is the minimum value, that is this. Okay, divided by LE square. LE is 2.3 meter. I have to put this in millimeter. So it is 2300 mm. Okay, so 2300 square. Now let us calculate this. Pi square, this is pi square into 2140 into this by 2300 square. Okay, so 163, just copy it. This is in Newton, so just take one decimal place, 32, or I'll just take 3 Newton, right? Because this is in Newton per mm square, I is in millimeter, length is in millimeter. So the stress that you get, the load that you get will be in Newton. Now let us find the Rankine's load. So for Rankine's load, I need K, right? LE by K. Or you can use the other equation for Rankine's load. Let me do that way. This one. Rankine's given by this, right? Now let us find PC and PE. I already have, so from this I can calculate P. Uh, we have compressive load is PC is equal to sigma C into A. Sigma C into A, which is equal to sigma C into BD, right? Area of cross section remains same in both the direction. That is not going to change. So sigma c is how much? 550, 550 into 45 into 55. So how much is this? 45 into 55 into 550. So this is the crushing load in Newton. Now you have to just put them in this equation. Now just copy this is equal to this, or when you cross multiply you get this equation, right? P is equal to PCPE by PC plus P. I'll use this. P is equal to PCPE by PC plus PE. So this is equal to, let me put the values now. PC is this much, right? Into PE is this much. By PC plus PE. So PE is this and PC is this, right? So let us try to calculate this. This into this divided by this plus this. So this is the Rankine's law. Just take one decimal. Okay. Now you have to write like this. The Euler buckling load is this many newtons. Is this many newtons, and Rankine's buckling load is right. 3 plus 3 6. This is 7. If you see the compressive load in the simple stress and strain first unit, this is how we have studied, right? When the column is subjected to a compressive load, the stress induced is compressive. So based on that, if you try to determine the load, maximum load the column can take, it is this much, right? 1361250. So it is a 7-digit number, 1361 kilonewton. Whereas Euler's is giving me 163 kilonewton and Rankine equation is giving me 146 kilonewton. So it is about 10% of the compressive load, right? So compressive load is 1361, and what I'm getting is 163 kilonewton or 146 kilonewton, right? So that is the effect of bending or buckling of the column.